are taking for the code reading session, and from today onwards the code reading session will be here only. So let's get started with Duri Tejaswar Reddy. Okay, you can start sharing your screen and present the code book IS 1893 part 1 2016 we are reading. So that code book only will be starting to read. So definition part, I think we have already done it last time. So we'll start with some clauses. Please open it. So this one we have already done it, okay. So this natural period and everything we have already done it. So spatial terminology for buildings, right hand side. You can go down. Center of mass, center of rigidity also we have done. Please go down. Go down. So these are basic definitions that is mentioned. Whomsoever was not there in the class, they can read out and let us know if you have any doubts in this definition section. Okay, these are very simple definitions that has been given, okay, by the codal guidelines. So these definitions are required to master this code. That's why these definitions are written over here. And also there are certain symbols which is also very important in order to solve certain equations and solve certain I would say concepts in order to address the earthquakes engineering part, okay, for the buildings. So go down. Yeah, so we'll start with the ground motion, okay. So there are also like certain principle and design criteria is mentioned, so we'll not put much time on this. So go a little down, we'll directly go to certain very important clauses. Okay, so these are the basic areas that basically we have already we have been known to this. So just let's start with the assumptions then. Okay, so the assumptions is very important. So I'd be asking Mr. Reddy to open the annotate option from the top so that I can annotate on your screen. There is a stop sharing. There is a stop sharing option beside your above your screen. So beside that stop sharing, there is an annotate option. Three dots. You click. There will be annotate.
No, sir, they are very
Shubham or Anirudh, can you help him once to open the annotate?
this one.
वो ऊपर beside stop sharing there must be some option which will be opening the annotate. It is not showing. Let me just check. Actually it's on from our end. I don't know why it is not showing. It's coming for me actually. I don't know. Start share once. Share the whole screen. Don't share only one particular portion. In the top there will be annotate option, right? There is a ribbon, no, like this. Teams ribbon.
It's there.
So click on annotate.
Annotate the control, share, option, layout, people. Only these are options are available, sir.
Annotate is not there.
Not there, sir.
Okay, so leave it. So just you can start reading the code. Okay, so let's start with the assumption portion. Okay.
The following assumptions shall be made in the earthquake resistant design of structures. Earthquake ground motions are complex and Irregular consisting of several frequencies and of varying amplitudes, each lasting for a small duration. Therefore, usually resonance of the type as visualized under steady states seen on a subtle existations will not occur as it would need time to build up such amplitudes, but there are exceptions where resonance like conditions have been seen to occur between long distance waves and tall structures founded on deep soft solids. Earthquake is not likely to occur simultaneously with high wind, maximum flood, or maximum sea waves. The values of elastic modulus Subham, Subham, sound come kar. The values of elastic modulus of materials wherever required will be taken as for static analysis unless more definite values are available for use in dynamic conditions. See IS 456, IS 800, and IS 1343, 1905, and 2974. Part 1 to 5.
Right.
Terms
Yeah. Proceed.
load combinations and increase in permissible stresses. Load combinations. The load combination shall be considered as specified in respective standards due to all loads effect mentioned therein. In addition, those specified in the standard shall be applicable, which include earthquake effects.
Yes, sir. Hello, sir. Yes, sir.
Mm,
Yes, safe.
Even
Anything? Yeah, proceed.
even when load combinations that do not contain earthquake effects indicate larger demands than combination including them, the provisions shall be adopted related to design. Ductile detailing and construction relevant for earthquake conditions which are given in the standard IS 13920 and IS 800. Design horizontal earthquake load. When lateral load resisting elements are oriented along two mutually orthogonal horizontal directions, structure shall be designed for effects due to full design earthquake load in one horizontal direction at a time and not in both directions simultaneously. When lateral load resisting elements are not oriented along mutually orthogonal horizontal directions as per 7.1 table 5E. Structure shall be designed for the simultaneous effects due to full design earthquake load in one horizontal direction plus 30% of design earthquake load along the other horizontal direction. The structure should be designed for the following sets of combination of earthquake effects. These are the formulas.
Yeah, so here I just would like to mention certain points. So can you please give me the access, Mr. Reddy? I have asked for the control. It's given. Okay, thank you. So as you can see, these combinations are very important. Just a moment. Yeah. So as you can see, these combinations that we are seeing over here is saying basically 30% of the component. Okay, so 30% component, why it is asking? Because as you can see, when the lateral load resisting elements are not oriented along mutually orthogonal directions. Okay, mutually orthogonal means suppose let's say there is a column like this, or if there is a column like this, generally columns are like this, right, for us. So this is any of the side, it is mutually orthogonal, means either in y or in x. Okay, so this is very helpful and needed for the newcomers specifically who are not habituated with the ETABS yet. Okay, so for them this orthogonal and non-orthogonal will create a lot of issues later on if you do not understand from now on. So this, if we call it as x, then this would be the y. right? So definitely you will be having a lot of issues if you do not understand this. So what is orthogonal axis? These two are called orthogonality, means which is x side or y side. Okay, so if certain columns are not oriented mutually to this orthogonal axis, which is either to x side or to y side, some column might be here also like this. Okay, some column might be here also, so this is not mutually orthogonal then. Okay, some column might be this kind of a column also are there. Okay, so this is one part, this is another part. Okay, this column is coming like, let's say like this, and there is a beam here. So there is a column which is like this, L-shaped column, but which is inclined. You will be getting a lot of columns like this. Okay, so this kind of portions might come in case of big structures which is having a podium at the bottom and then it is going top, and also certain peculiar geometry is introduced. So in those kind of scenario, this kind of non-orthogonal columns we call it as, okay, which is not mutually perpendicular or parallel to any of the orthogonal axis. The columns or the vertical elements which are not mutually parallel or perpendicular to the global axis or to the primary orthogonal axis, those columns are called, or those particular elements are called non-orthogonal element. Clear? Now, how to counter this non-orthogonal elements, that has been prescribed by the code, that whenever you are taking the force of spec x, means x side earthquake force, whenever you are taking, you take a component of 30% of that other side also, which is y side. Right? It means, suppose let's say if certain columns are oriented like this, and you are putting a x-axis force here, okay, in this particular column. So on the basis of this, there will be a local axis, there will be a global axis. Okay, so on the basis of this local axis, x force will be applied. But what about the y? There would be certain component in y also for this particular column, because it's not straight, it's an inclined one. So that component we are taking as 30% of actual y forces that is actually coming over here. Okay, so over total 100% is not required for the other side. You can take 30% along with x and 30% of y along with x and 30% of x along with y. That way. Means either of the direction you need to take 30% component. Why 30%? That has been told by code after rigorous analysis and rigorous case studies. Okay, so 30%, because this, whenever this comes, whenever there is any non-orthogonality, there is an introduction of components, sine component, cos component. Have you you have studied in trigonometry and all those things in college days, in school days, right? So sine and cos component comes in here. So that is not only x and y that time, it is x plus certain part of y and y plus certain part of x, that way. So 100% y if you were taking, no, so we are not defining this particular 30%, this is being defined by the code, this is not our definition. Okay, so since code has told 30%, we need to take 30% only, we cannot take more or less. Okay, so why 30%? That might be, I don't know, basically that might be there in some of the journals or some of the other places where some case studies has been done. Because code is all the codes, wherever you are getting certain values, it is based upon rigorous case studies and different experienced people are on board with at one umbrella. So they are deciding it after a rigorous discussion that how much you should allow for the other components. Because if you make this 30% to even 40% or 35% also, or 25% also, 20% also, there will be a huge change that you may observe, right? Because why huge change? Because this particular component creates a specific force in that direction as well. which may cause certain failure also sometimes in certain vertical elements, because whenever it is only x or when it is only x or only y, then it's a different kind of behavior. When some other components are coming in, then it's a different kind of behavior. So that way you should do it. Okay, so this clause do not forget to read again and again and again. Okay, it is very very, very extremely important clause. Okay. Okay, so this clause is very, very important. Yes, somebody else can start next. I think Shinu.
In this screen only I can read.
Yes, if he allows you, then you can. So there are certain doubts that I can encounter here in the chat section, sir, how to perform 3D analysis spec Z in ETABS. Yeah, on that we will be taking a separate session. It is very simple actually. What you need to do is you need to calculate the AV. Okay, that we generally calculate for AH, right? For base shear VB bar. Okay, so VB bar equal to AH into W, that is the formula. So AH is basically Z by 2 I by R into SA by G, right? So that we need to check. But in case of spec Z, it would be AV, which is vertical acceleration. AH is horizontal acceleration, but in case of AV, it is vertical acceleration. So over there, the formula is little different given by the code itself. That it would be like 2.5 into 2 by 3 into I by R. Okay, so that you need to take into Z by 2. Okay, so this is the formula. So what is the formula? So why 2.5, that also I'll tell you. 2.5 is the maximum value of SA by G. That code has directly told us to take that maximum value only. Just a moment, give me control back again once. Yeah, so what is the formula? Formula is 2 by 3. Is it getting written over here? Or just a moment, I'll just share my screen. Can you see the whiteboard?
Yes.
Yeah, so it's I'm writing, everybody's, it is visible for everybody. So 2/3 into 2 by 2.5 into Z by 2 into I by R. Okay, so this is the formula for AV. What is 2.5? This is maximum value of SA by G prescribed by the code. Okay, why is 2/3? That the entire force, whatever is coming from here, that you need to take maximum 2/3 of that. So this is for maximum component.
So that is in horizontal direction, sir. Maximum force.
Yes, basically this is from the horizontal direction only, the formula, right? So H formula is what actually? Z by 2 I by R into SA by G.
Yes,
So if this SA by G is maximum, which is 2.5, then this is actually H formula only. So
okay, into 2 by 3. H formula into 2 by 3.
That's what, correct. H formula into 2 by 3 is the formula actually, if you say. But since the code has directly told that you don't bother about the soil conditions or the time period for SA by G, you straight away take the maximum one. Okay, so that's why we are taking maximum value of the SA by G. So whatever this value will be giving, that you can put it in two formats. One, either you put entire thing in the function itself by creating a new function, which is, let's say you can create a function Z kind of a thing. Okay, so this function you can create and you can put this entire value inside that function. How to do that, I'll show you in a separate session. Okay, and also
Sir, whiteboard is not visible for me.
it is still not
It's
visible.
showing Microsoft whiteboard and
Network issue.
Can you see now?
Sir, it is visible, but you have to scroll down, sir.
something went wrong. Like something went wrong, it is showing.
What went wrong? Just a moment.
An error occurred while processing, like that issue.
Is it visible now? I have restarted.
No, sir. Just a
Participants.
minute. Yeah, yeah. Yes, sir. It's visible now.
Ah. I think everybody can see this now. Right? Okay. So this particular, so this is the formula for AV. Okay, so there are two ways to put this particular formula in the software. Okay, number one is you put this entire thing in function, under the function which is fz you need to create. This function is nothing to do with the previous one which you have created. So IS1893 you can name it and create a separate function over there, and over there you put this entire thing, okay, by calculating it, and in each time period you need to put that. So I'll just quickly show only. Let me just open the software. Wait. Okay, so can you see the screen? So here in the function you go to response spectrum. Already this response spectrum is created, right, for the horizontal portions. So now for the vertical also we'll be creating a new function, IS1893 2016 add, and convert it to user defined. Okay, so here you put it function z or any name you give it. Okay, and here you need to put basically that 2 by 3 into 2.5 into z by 2 into I by r. Okay, so this entire thing, whatever is there, that you can put it here in this value sections for each one. Let's say if the value is coming, let's say 0.5 for an example. Okay, so what you need to do is, let's say put 0.5 here. So everywhere you need to modify 0.5. Like that. Understood? So this period would be same. Period you don't need to change because this is a system generated time period for the dynamic earthquake, right? We do not give any kind of time period formula for it. So it is based upon the model that you have created. Okay, so like that everywhere you need to put that 0.5. So this particular curve, which is SAYG versus time period as per 1893, this curve will be in a single line where the component would be same saturated. Okay, so once you are done with this, then you can make it okay. Okay, let's say for an example you make it okay, and go to the load cases, and you can create a new load case over here with the response spectrum, and this would become spec z. Add a new function acceleration and make it a u3. u1 u2 already you have done for spec x and spec y, so it would be u3 and the function would be fz, and this would be as well as like as simple as g. Okay, so this is always g, right? Since you have put entire thing over there, so this would be only g. There is a second option which you can do, which I generally prefer to everyone to do that. So this 2/3 into 2.5 into I by r into z by 2, right? So from here few part, this 2 will be cancelled, right? So this 2.5 into divided by 3 into I divided by r into z. Currently this is the scenario. So certain portion you can keep it here in the function, and some portion you can divide it from here. Let's say I by 3r. So 2.5 into z by 3. So this portion you can keep it in function, and this I by 3r you can take out and put it here in the scale factor along with g. That also you can do. So basically you are splitting this formula in two parts. Okay, one is 2.5 by 3 into z. Okay, another one is I by 3r. So either you take I by 3r in the function and take 2.5 into z by 3 into the scale factor, or you take I by 3r into scale factor and 2.5 z by 3 into the function. Ultimately this is going to multiply. So wherever you put doesn't matter. Or if you put entire thing in the function itself, that is also okay. But in
So then here, sir, for in the first case you told that it is z, right, in the scale factor.
so what is the formula for VB? AH into,
So
if it is not Z, then AH into W. For VVZ, if we talk about, then also it is AV into W, right? So W is
Yes,
what?
sir.
W is the seismic weight.
seismic weight.
So that seismic weight is anyway given by the mass source. Now this AV, ultimately this will be multiplied by the G, entire thing, right? To get you the
Sir.
actual base shear. G means the initial scale factor here.
Okay, sir.
Okay. So this entire thing is basically multiplied with the G. So even if you take AV into the function or into the scale factor, ultimately it is going to multiply it with G along with
Yes, sir.
W. So where you put, here you put or there you put doesn't matter. So few part you can put it here, that many consultant does that this way. That few part they put it here and few part they put it in function. Or the entire part also you can put it in function. So there are two different method of doing it. Okay, so once it is done, once you are done with the scale factor and all, if you are taking the first method where everything you will be putting in the function only, then here only the 9806 will come, which is the gravitational constant or G. Okay, now if you want to split it, so in that case I by 3r you take it over there and this one you keep it over here. Okay, so whatever this value will come, Z, let's say 0.16 is the Z, divided by 3 into 2.5, whatever this value will be coming, that you multiply with G and put it as an initial scale factor. Then you run the analysis. You don't need to check anything for spec Z. What you need to do, you need to check the base shear, okay, just once. No need to check anything else. After that, whenever the spec X and spec Y base shear is finalized and you are opting for design, let's say spec X and spec Y is finalized and you are opting for design, before that there will be a final scale factor for this and this, right? So the maximum one among these two you will be taking and you will be putting it here by replacing the whatever existing value.
The values might change, sir, in the spec Z, then it will be equal to spec X and spec Y.
Yes, the maximum one.
Okay.
Ultimately it will be the maximum one between spec X and spec Y. Initially we will be taking it G into the whatever these values are there, or only G as a initial scale factor. But after that, when the finalization of spec X and spec Y is done, that time you need to put it over here. And then what you need to do is in all the combination, wherever spec X and spec Y is there you need to take the spec Z also. Okay? What percentage you need to take, that has been told by the code. Yeah, so can you see this?
Yes, sir.
So 30% of the z axis also that you need to take as per 6.3.4.1. Okay.
Hello, sir.
Yes.
Sir, in ETABS, how to do that? Actually, I'm
Means?
not getting the things you are writing on the board.
See,
Yes.
ETABS में कैसे लेना है, इधर एक spec z बनाओ.
Okay, sir.
Already I have explained this in the class also. Okay, so this is one is it is done. You take this minimum eccentricity. Okay, okay. Then go to combination. Whatever the combinations are there, go inside that wherever the earthquake is there. Spec X, let's say. So this earthquake would be there, right? So take the 50% of it. Sorry, 30%, not 50%.
30%.
Okay, so this is for this thing. So 1.5 into 0.3 होगा इधर. So 0.45 will come. So it will become
Yes,
plus 0.45 spec z.
Spec Z.
Like that everywhere you need to do it. Wherever spec x and spec y is there. If there is any non-orthogonal column, then this is the scenario. If there is a non-orthogonal column, then you need to take spec y also here.
Yes.
Right? Sorry, spec y, right? This one. Okay, so this would become the combination if there is a non-orthogonal case. Understood? So 30% of spec z, 30% of spec y, and 100% of spec x. Okay,
Okay, sir. Understood.
likewise we will be going for same manner. Okay, if it is a spec y, then this would become spec x.
Right, sir.
Understood everyone? Loud and clear? If
Yes, sir.
any doubt is there, let me know, because this portion is little critical, I know. So it might be little confusing also for you later on. So please get it clarified now itself.
Sir, this spectrum would create any deflection, sir, in the vertical direction, user direction.
Yes, UZ, no. For UZ it will not create any problem. For spec Z, the component itself is very small. It's just 30% of the entire component. So I don't think it would be creating any problem. Anyway, if it is creating, you are taking that combination into the design. So your design would be in sync with
It
that.
isn't safe.
You don't need to check any deflection or anything for spec Z. What you need to do is you need to just take this into this design combination. That's it. So during the design, this component should be there. Generally, why we do this spec Z is because for the large cantilevers or for different kind of
Like re-entrant corners.
yes. So which has been told already in the code, right? So if you
Yes.
check, see
Structure zone
seismic
4, 5.
zone 4 and 5.
4, 5, soft soil resting on the structure.
Yeah.
Like
These are the
openings.
things. Okay.
Sir, I have one question. I mean,
Yes.
which method is best, sir? SRSS combination or 130 rule?
130 rule is there in almost everywhere of structural engineering. Which 130 rule you are saying? It is there in pile foundation also.
No. I mean, in orthogonal axis.
See, SRSS combo is a different thing.
Yeah.
Okay, SRSS we are doing for what? For solving modal. What is SRSS? Do you know?
Square root of
Okay. So for SRSS, the comparison should be there with CQC. Okay, so this is complete quadratic combinations. Okay, so SRSS means square root summation of square and complete quadratic combinations. It's a very deep subject actually. I'm telling you in a very nutshell. Okay, so what is the basic difference between these two? Whenever you are using SRSS, okay, the software will not consider any kind of inter mode discussion. For an example, let's say mode 1, 2, 3, 4, 5. Okay, like that. So first mode is having, let's say, 60% translation, 40% rotation, and 1 second time period. For an example, I'm just giving a very vague example only. And this is having, let's say, 0.6 second time period, 70% translation, 20% rotation. This is having 0.5, which is second, which is having, let's say, 70% rotation and 20% translation, like that, and so on. Okay, so what are this particular mode is trying to say? So whenever these modes, each mode is distinct, means away from each other by 10%. Okay, so when these modes are very important, this is okay, this particular topic, please understand it very deeply. I'm trying to make it as simple as possible. Okay, so when these mode shapes or modal time period or modal behaviors are distinct from each other, means there is no chance or there is no possibility of the first mode becoming second or the second mode becoming third. So the modes are equal. It is very distinct mode. If it is, then we will be opting for SRSS. Why? Because it basically calculates each mode behavior separately. Okay, it doesn't create any kind of inter-mode discussion. Okay, whereas in CQC, if you talk about, it's basically giving some coupling moment also in between the modes. Okay, so what is coupling moments? Let's say, for an example, first mode is having a very it is not distinct. Let's say there are 50-50 or 40-38. Along with that, next mode is also 40-38. Sometimes we need to proceed also with this kind of behavior due to certain improper geometry or something. So if you see that the modes are not distinct, it can become certain inter-mode discussion can start. Means some modes can be talking to each other, or there would be certain coupling effect between two modes. So it is not a distinct mode. So that time there would be the CQC combinations that you need to take. So it is already mentioned in the code, this software itself. So if you go to this load case response spectrum, here there is a modal combination method. So CQC and SRSS, these two are generally we are using. There are many other, those we generally do not use. For SRSS, if you are using, then definitely you are not considering any kind of coupling effect between the modes. But if you are using CQC, okay, it means you are actually taking the real-time scenario where the coupling, where the different mode discussion can also create certain issues, and that issue will be taken into the consideration. There is another way of discussing about SRSS is directional combination, which is written here. I think that was actual question of Ranil, that where the plus is the only thing, there is no minus, right? So SRSS combination is always better to take for the non-orthogonal cases. Okay, you can go with the EX also, but with EX if you go, then you need to take plus minus. Okay, so that way. So the SRSS is also having two parts. One can be done with spec X, another can be done with EX. So that's what I have told. If you are taking with spec X, then there will be only plus. If you are taking with EX, then will be plus and minus. And 130 of this orthogonal, non-orthogonal, if you take directly, you can take it in combination. So any one of these two you can use actually. Both are correct. Okay, so what generally in Econstruct in the workshop maybe sir has told about SRSS combinations. So that also you can use and you can proceed. But code has told about 130. So that also you can check by creating that once and check the base shear difference, and accordingly you can proceed.
डिजाइन में सर वो जो कॉम्बिनेशन में करते हैं तो अन्य नंबर
आपका वॉइस नहीं आ रहा है प्रॉपरली. सीनू प्लीज मेक इट म्यूट. हाँ, कम अगेन.
जब एसआरएसएस मेथड यूज करते हैं कॉम्बिनेशन में तो तब अनइकोनॉमिकल डिजाइन हो जाता है, रेनफोर्समेंट परसेंटेज बहुत ज्यादा हो जाता है.
हाँ, तो इसीलिए 130 लेना पड़ता है उस टाइम. देखो SRSS कॉम्बिनेशन आप यूज कर सकते हो, लेकिन 130 कॉम्बिनेशन इज also told by the code, right? So you can check both, and you know, base shear difference also you check how much it is coming. Not base shear difference, the design difference actually. Okay, so if always you cannot take SRSS combination, that is probably not possible. But this is also is one of the methods. सारे जगह पे नहीं होगा उतना ज़्यादा. Everywhere it will not be that much big value. But where the earthquake is governing to a very very big extent and there are many non-orthogonal columns, in those places it might govern.
Sir, if building was a orthogonal, then not vertical element, building, whole building is orthogonal.
For that, so anyway you are going to give the 134 anyway. Okay, in all the columns. So if it is all the columns are this thing, then you know force would be anyway more, because the entire building would be designed for that. But if certain few columns are non-orthogonal, then the problem comes actually, because those columns would be getting very heavier. Let's say for an example, there is a column beside which is orthogonal column, and there is a column just next to that column which is non-orthogonal. Hell and heaven difference would come between these two columns in terms of reinforcement. So that is very difficult to execute at site also. But if entire building is non-orthogonal, then everybody will be going at the top stage. It will be like more only. So that time some components gets cancelled out also, like gets nullified. But if one or two columns are more, then you can't help. Are you getting what I am trying to say?
Yes.
And generally if the entire building is non-orthogonal, generally that kind of scenario happens in a big structure which is high rise. Okay, very small structure, that kind of non-orthogonal shape you will get very less. Okay, if it is a non-orthogonal, mostly it will be like a for the facade and all these things they have done that kind of geometry. Okay, so if that is the case and if it is high rise, then earthquake will never govern only. It is the wind governing structure. So that time wind tunnel will be coming in. So that way. So this non-orthogonal case is generally threatening for the mid-rise structure, where the G plus maybe 20, 25 maximum till that. If it is beyond 30, it's wind who is going to govern. Are you getting? G plus 80, 90 story building if you design. Okay, as per 16700 new time period formula, the earthquake would be nominal. It would be nothing.
Base shear of earthquake.
Base shear would be drastically reduced as per new formula if you check tall structure code.
Yes, sir.
But whereas wind would be like predominant, crazy. Understood?
देखा है सर 3000 और एक 10,000 का डिफरेंस आया था.
So like that's what in your that project also. See, Avranil has done one project where he has just done one thing wrong. What he has done wrong is he has taken the breadth of the structure little more. Okay, I think 6 or 7 meter more. Okay, so I have reduced that breadth and 150 kilonewton, or I think 150 kilonewton or 150 ton, 150 tons or 150 kilonewton, sorry, 150 kilonewton force got reduced, okay, in one go, just for one breath. So that is for the gust, but for wind tunnel that scenario is completely different, because there would be different consultant who will be doing that. Are you getting what I am trying to say? So these are very, very deep topics. I know a few people might be thinking that what the hell is going on, but it is there in your thing, maybe today or tomorrow. Okay, so don't get frustrated or something. It's very normal. So something has been told by Subham, that is it applicable to beam slab also? No. For the beam slab it is not applicable. It is for the vertical elements only. Beam slab is not in that, non-orthogonal is not there for beam slab and all these things. Okay, because it depends on the local axis. Beam slab is nothing to do with global axis, but the column is something to do with the global axis. That's why this particular effect is there with the vertical elements more. Okay, so Shinu, you can start reading from the next clause onwards. Please share your screen, Mr. Reddy.
Sir, that the 130 is applicable for also, or what?
No, 130 is only for columns. For that particular floor, actually, if it is fully non-orthogonal, but generally column will be predominant for the design changes.
Okay. Thank you.
You will hardly get some changes for beams and slabs. It would be hardly something. So if you're taking that, not taking that doesn't make any difference. But in columns, yes, because their axis only gets changed completely in terms of global axis that way. Yes, beam slab would be also having certain very, very nominal changes, but yeah, that is there. I'm not saying that it will not be there, but if in case of the entire building is non-orthogonal, that case. But if it is one or two components, then beam slab might not be the non-orthogonal anyway. Only one or two columns might be there. Okay, that way. Yes. Clear, Akhil? Where is Akhil?
Yes, sir, it is clear. It is clear, sir.
Yeah. Please share the screen. What happened? Share the screen, please. Or shall I? Wait. So where we have stopped? We have stopped here, right? Yeah, Shinu, you can start reading from here.
Thus, EL in the load combinations given in 6.3.1 shall be replaced by ELX plus or minus 0.3 ELY or ELY plus or minus 0.3 ELX.
Correct.
Hence, the sets of load combinations to be considered shall be as given below.
So already we have discussed about this. What we need to do is we need to basically multiply the existing factor with 30%. Okay. Yeah, proceed.
1.2 times dead load plus DL plus IL plus
Directly go for 6.3.
6.3.3. Okay. Design vertical earthquake effects. 6.3.3.1 effects due to vertical earthquake shaking shall be considered when any of the following conditions apply.
Correct.
Structure is located in seismic zone 4 or 5. Structure has vertical or plan irregularities. Structure is rested on soft soil, bridges. Structure has long spans or structure has large horizontal overhangs of structural members or subsystems. When effects due to vertical earthquake shaking are to be considered, the design vertical force shall be calculated for vertical ground motions as detailed in 6.4.6. Where both horizontal and vertical seismic forces are taken into account, load combinations specified in 6.3 shall be considered. Combinations to account for three-dimensional earthquake ground shaking.
Then just hold on a sec.
I can't. Sir, you are sharing.
Yeah. Is it visible?
Full page. Okay.
You are reading from my code only, right?
Yes, yes.
Okay. Yeah. Yeah. Can you see?
Yeah. When effects due to vertical earthquake shaking are to be considered, the design vertical
Yeah. When the effects due to vertical earthquake shaking are to be considered, it's not visible.
the design yeah. It was moving actually.
Okay.
The design vertical force shall be calculated for vertical ground motion as detailed as 6.4.6. Where both horizontal and vertical seismic forces are taken into account, load combinations specified in 6.34 shall be considered. Combinations to account for three-dimensional earthquake ground shaking.
It's not three-dimensional, it's three-directional.
Three-directional.
Yes.
When responses from the three earthquake components are to be considered, the responses due to each component may be combined using the assumption that when the maximum responses from one component occurs, the responses from the other two components are 30% of each of their maximum.
Correct. So this is very important line, guys. Okay. So if one the assumption, this is the assumption actually, when responses from three earthquake components are to be considered, the responses due to each component may be combined using the assumption that when the maximum response from one component occurs, the responses from other two components are 30% of each of their maximums. So this is very important line that you need to note it down. Yeah, please proceed.
All possible combinations of three components ELX, ELY and ELZ, including variations in sign plus or minus, shall be considered. Thus, the structure should be designed for the following sets of combinations of earthquake load effects. A, plus or minus
no need to
ELX
read that.
plus.
No need to read that.
Okay.
You can proceed. You can proceed directly here. These combinations we have already discussed, so you can go to the 6.3.4.2.
As an alternative to the procedure in 6.3.4.1, the net response EL due to the combined effect of the three components can be obtained by EL equal to
So this is basically Abranil's questions answer. Okay, so this is basically the SRSS combination which you are saying, right? SRSS means square root summation of square, right? Yeah. So
caution may be exercised. Caution may be exercised on loss of sign, especially of the axial force, shear force and bending moment quantities when this procedure is used. It can lead to grossly uneconomical design of structure.
Correct. So this caution is there. It is written. Caution may be exercised on loss of sign, especially of the axial force, shear force and bending moment quantities when this procedure is used, it can lead to a grossly uneconomical design of structures. So that's why SRSS combination is little difficult to use all the time. So if it is a small structure, you may have use it, but if you do not take the plus minus components, then there will be a issue with the economy that they have told it over here. Loss of sign, that is the term here. Yeah, from next Anirudh can continue. Six point 3.4.3.
Okay. Procedures for combining shaking effects given by 6.3.4.1 and 6.3.4.2 apply to the same response quantity. Say bending moment in a column about its major axis or story shear force in a frame due to
Have you
different components
connected
of the ground motion.
Basavaraj with this guy, Simon Musa?
The next one also, sir.
He came, no? Simon.
6.3.4.4 when components corresponding to only two ground motion components, say one horizontal and one vertical, or only two horizontal, are combined, the equations in 6.3.4.1 and 4.2 should be modified by deleting the term representing the response due to the component of motion not being considered. Increase in net pressure or soils in design of foundations. In the design of foundations, unfactored loads shall be combined in line with IS 2974 while assessing the
उसके
bearing
साथ
pressure
connect कर
in
दो ना इसको.
soils. 6.3.5.2 when earthquake
This guy.
forces are included.
इनका कुछ issue है teams का. एक बार
Included net
बुला
bearing
लो ना.
pressure in soils can be increased as per table 1 depending on type of
उसका teams
foundation
open नहीं
and
कर पा
type
रहा है
of
वो.
soil.
Just talk to
For
him.
determining the type of soil for this purpose, soils shall be classified in four types as given in table 1. In soft soils, no increase shall be applied in bearing pressure
Afternoon.
because settlements cannot be
He's from
restricted by
this place
increasing
actually,
bearing pressure.
Africa. Just give him the timing there.
6.3.5.3
Just call
in
him
soil
and give him the
deposits
timing.
consisting of
Okay,
submerged
or
loose sands and
text him that I
soils
am the
falling
teams
under
expert from
classification
Econstruct.
SP
So I'll
with
give him.
corrected standard penetration
He
tests
has come
values
already.
N
You just tell him in the
less
Zoom
than
only.
15 in seismic zones 3, 4 and 5 and less than 10 in seismic zone 2. The shaking caused by earthquake, ground motion
उसको
may
उनके साथ
cause
connect करवाओ.
liquefaction or excessive total and differential settlements. Such sites should
बोलो
be
5 मिनट के लिए
avoided
सेशन ले लेने के
preferably
लिए.
for locating new structures and should be avoided for locating structures of important projects. Otherwise, settlements needs to be investigated and appropriate methods adopted of compaction or stabilization to achieve N values indicated in note 4 of table 1. Alternatively, deep pile foundations may be adopted and anchored at depths well below the underlying soil layers which are likely to liquefy or undergo excessive settlements. Also, marine clay layers and other sensitive clay layers are known to liquefy, undergo excessive settlements or even collapse. Owing to low shear strength of the said soil, such soils which will need special treatment according to site conditions as per table number 2.
Yeah.
Simplified method is given in annexure F for evaluation of liquefaction potential.
Yeah, so liquefaction is also one of the very important topic. In Bangalore recently one building has fall down. Have you people seen that video? Okay, so in few years back there was a flood also in Kerala. So the both of this occurrence happened because of the liquefaction. Okay, so basically liquefaction is what? When the soil shear strength, okay, shear strength of soil becomes zero. So soil starts behaving like liquid. Are you getting what I am trying to say? So generally soil is what? Soil is a material which is having some mass, right? And definitely whenever mass is involved, some shear strength would be there. So when that particular mass becomes, start behaving like a liquid, so there will be no hold, no strength to hold the things, so it will just washed out. So that situation happened, and it is like, it is nowhere, the foundation is nowhere, actually it's flying in the air. So the building is like overturned and fall down. So same thing happened in Uttarakhand also long back, once that Kedarnath temple was there, which was only there because of pure rock anchoring effect. Other than that, everything is gone. Okay, because it's a pure liquefaction effect of soil. So shear strength becomes zero completely. Okay, so make sure that this kind of liquefaction also, wherever the flood prone areas, mainly for the flood prone areas, you should check the soil layers for anchoring effect also if you are dealing with the bigger structures. Okay, that's why pile is required, because of these reasons. For the marshy soil, you can't put the piles or put the footing in a layer where it is prone to certain very very sudden failures. You need to have a stable layer to put the foundation in any structure. It might be bigger structure, smaller structure, whatever structures it is, you need to have a better layer. You need to have a complete profile of that layer below. Sometimes what happens, there are some dummy layers. Okay, sometimes there are some dummy layers. What do you mean by dummy layers? Suppose let's say there is a sand, all of a sudden you will be getting a rock. So that rock you cannot rely upon. You need to go 2-3 meters more to check whether this rock is there throughout or not. Sometimes what happens, in between there is a layer of rock, again there is a bad layer below that, maybe after 1 meter, 1.5 meters. So this is called a dummy layer. Okay, so if one geotech consultant or any specialist, rock mil gaya, you will stop. After that will not go. Don't do this kind of mistakes. Even wherever you are resting the foundation, below that also you check the layers. Understood? So that way. So I think rest of the things are well self-explanatory regarding this different net pressure in soil, foundation and other areas. Yes.
Sir, can you please explain the clause number 6.3.5?
Increase in net pressure on soils in design of foundation. So it has been given already, right, by certain table. Yeah, so this is the one. Percentage increase in net bearing pressure and skin friction in soils. Okay, so for different kind of soil type, you can increase certain percentage of SBC. Okay, that has been prescribed by the code. So this will only include if you are taking earthquake loads, then only. Okay, abhi, you are taking dead load, live load analysis in the foundation, and you are increasing the soil bearing capacity since it is a rock soil. Don't do that, because earthquake is at itself not there. If you are taking earthquake, then only this clause will be applicable. So it is written specifically that, yeah, so if any increase in net bearing pressure has already been permitted for the forces other than seismic forces, the increase in allowable bearing pressure when seismic force is also included shall not exceed the limit specified above. Means what? If you have taken already some help of increasing net bearing pressure, sometimes group pile actions, 10% to enhance the capacity. So that 10% you need to take in between this range only. So it will become 40% then. Okay, so it should not exceed this much at any circumstances. Yes. हाँ sure. ठीक है. Okay. So understood? So abhi, what you need to do is next class, I'll not extend this class anymore today. I'll just finish it, like close it here only. Next class onwards we'll be starting with the H formula. Okay, so like everybody needs to read whatever we have read today, and I'll be taking a small interview kind of a thing, quiz kind of a thing in the beginning of code reading session next day. Okay, whatever you have already read, on the basis of that. Okay, and for senior people there will be some tough quiz also, who are little seniors. Okay, for juniors, whatever we have already read till that much. Okay, any other things? All right, thank you so much guys, and please attend all the sessions that we are taking.